Hello guys, in this lecture we are going to discuss about perceptron, and we are also trying to cover what is single layer perceptron and what is multi-layer perceptron when we are going to use single layer as well as the multi-layer. These concepts we are going to discuss today. So as we all know, the perceptron is a word which is invented by the person in 1957. So for this perceptron, the basic mathematical model we need to have, that particular model we are going to call this as a perceptron learning model. So which is inspired by biological neuron. So in simple, we can call this as a perceptron or as an artificial neuron. Artificial neuron is also called as a perceptron, which is a simplified model of biological neuron which is developed by 1943, which is the initiation where the biological neuron will be inspired. But with the inspiration of biological neuron, they invented the artificial neuron, purely which is working on the basis of biological neuron. For that, in 1943, they designed a mathematical model, simple perceptron learning model. So with that model, these artificial neural is with that particular model, the artificial neurons are going to be worked. So as this is the basic architecture of neural network. In any neural network, we are going to have multiple neurons, and here we can call this as a BIOS, and these are the inputs here. These inputs are processed by these weights to sum that particular input weights. So whatever the input weights we have, xi into wi weights, these are going to be summed. Then after we are going to apply some kind of activation function. So in the case of linear as well as non-linear, in the case of non-linear as well as linear classification, we are going to apply various activation functions. In the case of linear classification, we are going to apply the activation function which is to be supported for linear data. And in the case of non-linear also, we are going to apply the activation models which are related to non-linear data, which can handle non-linear data like MLP, Multi Layer Perceptron. So here, in general, the basic algorithm which is used to perform the perceptron is supervised learning algorithm like linear regression, SVM, and decision tree. Like this, there are various supervised learning algorithms are there. So based on these algorithms, the perceptron model is going to be worked. That's why we are calling this as a simple mathematical model, perceptron learning model, which is to be used to train that particular neuron, artificial neuron we can say. So in this process, whatever the algorithm we are using, this algorithm used to enable the neurons to learn the data from the weights as well as the inputs provided by the user. So these neurons are, how many neurons we are going to have in this particular architecture, that purely depends on how many features we are going to extract it and what is the basic requirement for that particular architecture. Based on that, we are going to incorporate a number of neurons in that particular hidden layer. So here, the inputs we have, weights we have, these inputs and weights are used to process the data during the training. Each and every feature will be extracted, or each and every feature will be processed at one time to corresponding to adequate that corresponding data. So in this particular model, these are the various components we are going to have: input layer, weights, bias, activation function, output, as well as the training algorithm. As I said now, the training algorithm may be any one of the supervised learning algorithms. So with the help of that algorithm, we are going to train that corresponding data. As we discussed in the previous lecture, there are 4-step process, 1, 2, 3, 4. So once the inputs as well as the hidden layer are transformed, then hidden layer 2, second hidden layer transformation, then third output layer, then at last we are going to train that corresponding model. So during this training process, these are the various components we are going to have in this perceptron. Input layer will interact with the real-time environment to access the various inputs from the real world. And weights are the processed data. That is, when you are processing that particular inputs which are accepted by the real world, which are accepted from the real world, to process that inputs, we need to have that corresponding weights. Then bias is simply, you can say, plus or minus. That means we are giving a flexibility for the model to up to a particular constant, whatever the constant we are using. For example, I am using plus or minus x. That means I am giving the flexibility for this model to get the result as the final result as plus or minus x. That means we are giving some kind of flexibility in the form of bias. Activation function. There are various activation functions are there to transform the data into linear to nonlinear, or to introduce the nonlinearity into their corresponding data. For that, we are going to use any activation function. Among them, step is one activation function, ReLU is one activation function, sigmoid is one activation function, tan h is one activation function. Like this, any one activation function we can use during this particular output. Before transforming the data into output, we need to apply the activation function so that the pure linear data will be transformed into the output in the form of binary classification. So in this case, the output is either 0 or 1. Then training algorithm, we need to have to train the model. Once the model was constructed, we need to go for the training algorithm. So there are two types of perceptron models are there. One is called single layer perceptron and second one is called multi-layer perceptron. First, let us discuss about single layer perceptron. So in this case, the single layer perceptron is going to have two layers. One is called input layer and the second one is called output layer. No hidden layers are introduced, or no hidden layers we are going to have in this particular architecture. So in the case of single layer perceptron, we have input layer with multiple neurons and we have output layer with multiple outputs. So each and every input is connected to all the outputs which we have in our particular network. So first is connected with 1, 2, 3. Second is also connected with 1, 2, 3. Third is connected to 1, 2, 3. Fourth is connected to 1, 2, 3. Fifth is connected to 1, 2, 3. So this kind of connections, we can call this as a dense. So one-to-one interaction we are going to have. Each and every neuron from the input layer will be connected to every neuron in the output layer. This is called dense architecture. So because of this architecture, every weight is processed by each and every neuron in that particular structure to process the output as to extract the more number of features from the input. Now, so in the case of single layer perceptron, this is very simple structure of artificial neural networks. So which is a kind of feed forward network. That means what? From input layer, we can transform the data to output layer, but from output layer, we cannot transform the data back to input layer. That is, back propagation is not applied. We cannot apply any kind of back propagation in this particular architecture. That's why we'll call this as a feed forward network. So which includes threshold transfer inside the model, just a kind of bias we are going to have. So inside the model, we are going to introduce that bias in the case of single layer perceptron. As I said, now it is consisting of input layer as well as output layer, but no hidden layers are introduced in this particular architecture. So each input feature is assigned with a weight to process this particular connection. For example, there is a first neuron is connected with the first output. In that case, to process this, we need to have some weight here. For example, W11. Like this, each and every connection is going to be having weights. So that input feature assigned with weight, and weighted sum is processed through the activation function to produce the output. Here, before producing the output, we are going to apply some kind of activation function to transform nonlinear data into linear format. Here, so when we have linearly separatable data, in that case, we can apply single layer perceptron. For example, I want to find spam. So I'm going to design one algorithm to detect the spam in our mail. What is the outcome we are going to have? Whether yes or no. that is 1 or 0. That means what? If the spam is found, it is going to produce S as a result or 1 as a result. If spam is not found, we are going to get 0 as the outcome. In the same manner, if any outputs like yes or no, do or don't do, like this, in these cases, we are going to use single layer perceptron. We are going to get only one single layer, either 1 or 0 as output. So that's why we'll call this as a single layer perceptron. The basic advantages are these kind of architectures are very simple to understand and we can easily implement. We'll try to implement with a Python code. How to implement the single layer perceptron also we are going to discuss now. So which is efficient for the problem straightforward as well as linearly separatable data. That means where only two decisions are there, either true or false. In this case, we are going to apply. But in the same manner, for this single layer perceptron, we are going to have some limitations also. It cannot handle non-linear problems. As we discussed in previous lecture, that is the logical gates called OR, NOT, XOR, X0. So these kind of problems we cannot solve with the single layer perceptron because these inputs we are going to have in non-linear format. So the non-linear format will not be handled by the single layer perceptron. That's why that is a difficulty in SLP. That is, we cannot handle non-linear problems or the complex data patterns. When the input data is having the complex patterns, when the input data is having the complex patterns, in that case also, the single layer perceptron cannot handle this kind of data because it is having the limited ability. To learn as well as the relationships with that particular data. When multiple inputs are provided as an input, so this particular SLP is going to have the limited ability to learn the features when multiple inputs are produced, when multiple inputs are transformed as an input here, and at the same time to find the relationship among these inputs, it is also difficult for the single layer perceptron. So to overcome this particular problem, we have an alternative solution called multi-layer perceptron, which is also similar to single layer, but only the difference is in between input layer and output layer, there may be multiple hidden layers. Any number of hidden layers you want, you can keep any number of hidden layers in between input layer and output layer. At the same time, each hidden layer is going to have multiple neurons. Any number of neurons we can keep here to extract the features. Usually, when the features are more number of neurons we are going to have at each layer and more number of layers we are going to have in that particular network. That purely depends on how many features we are extracting. If 10 features we are extracting, 10 neurons I am taking at the first hidden layer, and then some 5 neurons I am taking at the second hidden layer, 2 at the third hidden layer. Like this, any number of neurons we can keep in that particular architecture. So when we have non-linear data, when we have complex patterns in our data, in that case we are going to use multi-layer perceptron. So here also we have advantages as well as the disadvantages. So we can solve the complex problems, handling relationships, then we can use the deep learning applications like image recognition, speech processing, and NLP. So in these application areas, we can apply this multi-layer perceptron. When we come to the limitations, it requires large amount of data. When the data is more, then only we can use multi-layer perceptron because the more processing power is required, more computational power is required, more data is required. So whenever we have less amount of data, this MLP may not perform efficiently. So when we have large amount of data, when we have the hardware capacity to process the data in very faster manner, large amount of data capacities, in that case we can apply these limitations. When we have lesser amount of data, we cannot apply. So the data is more. In general, the processing power should be more. More computational power is required. For that, instead of using CPUs, we can use GPU or TPU based on the size of the data, and based on the processing capacity, we can use any one of these computational hardware. So more complex training due to backpropagation as well as optimization algorithms. So to apply the optimization as well as backpropagation mechanisms, this particular MLP needs more training because the data is having complex features. More data we have, so it needs more complex training is required to get the efficient results. At the same time, there may be a possibility of overfitting. That means instead of performing one operation one time, the same operation will be performed for multiple times. So when overfitting is occurred because of irregularized formatting of that particular data, that is, imbalanced data will be converted into balanced data. During that time, if we apply multiple restrictions, in that case, we may face the problem of overfitting. In that case, the data size is going to be drastically reduced. When the data size is reduced drastically, definitely the outcome is also a big problem in the case of multi-layer perceptron. So if we compare both the models, we have one input layer, one output layer in the case of single layer perceptron. In this case, along with the input as well as output, we are going to have multiple hidden layers. Here, linear problems can be solved by both the models, but non-linear problems can be solved by only multi-layer perceptron. Learning algorithm, any learning algorithm we can use here, backpropagation as well as gradient descent boosting algorithms can be used here. Activation function, in the case we are using step function, in the case ReLU, sigmoid, tanh, and softmax, any activation function we can use in the case of MLP. Low computational power, high computational power. Simple classification task, it is going to produce either 1 or 0 as output, only one output it is going to produce. And in this case, multi-classification mechanism we can apply. That is, multiple classifications we can get here, like image processing and regression analysis NLP can be applied here. Simple and limited complexity we have, and powerful as well as the complexity is also more in the case of multi-layer perceptron. Now, the big question is when to use single layer perceptron, when to use multi-layer perceptron. In this case, when we have simple binary classification, like I told, if the mail is having spam or not, if the decision is yes or no, in that case, we can go for the single layer perceptron, which are linearly separatable. When we have the data which is linearly separatable, that means when we have a data, we can divide the data into two parts with a simple straight line. So by drawing a simple straight line, I can divide, this is one category of data, this is one category of data. So in this case, we can apply single layer perceptron. For example, we have some neurons are there here. Now, these neurons I want to divide into 2 or 3 parts. For example, I am dividing these neurons into 2 parts. Now, if I draw one particular line, if I divide one category above the line, second category below the line, then we can call this as a binary classification. For this, we can apply single layer perceptron. Then, when we come to the multi-layer perceptron, this is multi-layer perceptron. In the case of image recognition and computer vision tasks like handwritten digit. For example, I am writing some digit here. Let us assume I am writing 9. Some people write like this. Some people will write like this. Some people will write like this. Different formats we can apply. Like this we can write. So when the system is going to read this particular character, it has to identify, because the handwritten of one person may vary with the other person. So if you write the digit in any format, that particular system is going to identify exactly what kind of digit that is. So in such cases, we can apply the multi-layer perceptron. At the same time, when you are applying LLMs, large language models, or social media sentiment analysis, or classifying the text, in that case also we can apply stock price forecasting. Then when the classification and regression problems, that is machine learning, basic machine learning algorithms like classification and regression algorithms, where if you want to extract the features very deeply, more number of features if you want to extract, in that case also we can apply multi-layer perceptron. So if you want to implement single layer perceptron, this is a sample code I'm using here in Python. So I'm using the libraries, standard deep learning libraries. I'm using TensorFlow as well as Keras. So these two models I'm using in the case of deep learning implementation or single layer perceptron implementation. So TensorFlow is for extracting the features like deep learning. Then Keras also, I'm using the model called sequential model. Then I'm importing dense here. Dense means one-to-one connection. Sequential means multiple operations which are to be performed in sequential order. That is one layer, then after second layer, then after third layer, fourth layer, like this it will continue in the case of sequential. Dense means how many neurons we have in each and every layer. For example, in the first layer we have 2 neurons, second layer 3 neurons we have, for example. In this case, first is connected with everyone, second is also connected with everyone. This kind of structure we can call this as a dense. That means I am giving instruction for the Python, create a dense structure. How many layers we have in that? That number of each and every neuron is going to be connected with every neuron which is available in the next layer. Then I am defining the model here. My model is sequential model. A number of connections are dense connections I want to use. Then 1. How many neurons we are going to have in this particular structure? Because it is single layer perceptron, I am using only one neuron at the hidden layer. We have input layer, hidden layer, and output layer. As the single layer perceptron is not going to have any hidden layer, so as a single layer perceptron, this particular hidden layer is not available in this particular structure. So that's why I'm using one neuron at the input layer and I'm producing output at the output layer. There is no hidden layers here. Directly, these neurons are to be connected. Then I'm using the activation function called sigmoid activation function here. Before producing the output, I'm going to use sigmoid activation function. Then input shape equal to 2. At the input, I'm using 2 neurons. So at the input, I'm using 2 neurons. One, no hidden layer is available. Activation function, sigmoid activation function before producing the output. Then I'm compiling optimizer. SDG I'm using. The optimizer we are using here is SGD, stochastic gradient descent algorithm we are using here. Then binary cross entropy to minimize the loss from the whatever the output produced by one layer to transform as input for the second layer. I want to minimize the loss here. To minimize the loss, we are using binary cross entropy. Then metrics, I want to calculate accuracy. That is, how much accuracy we are going to get after processing the output. In general, total number of that is number of positive results we got divided by total number of results. If by this we can calculate the accuracy here. So this is a simple Python model to design single layer perceptron. That means input layer. In the input layer, 2 neurons we are going to have. Output layer we have 1 neuron. This is going to produce either 0 or 1. This is a simple structure where we can use single layer perceptron. In the same manner, just you want to implement multi-layer perceptron. I am using this model as sequential model again. That means one layer by another layer, I want to process the data. Then dense 16 I am writing. That is the number of neurons I am taking is 16. That means one input layer we have, hidden layer we have, second hidden layer we have for this, and then output layer we are going to have. That means according to this model, we are going to have two hidden layers in between input layer as well as the output layer. Then dense layer, 16 neurons we have. That means at the hidden layer 1, we are taking 16 neurons. 1, 2, 3, 4 up to 16 neurons I am taking. At the second hidden layer, I am taking 8 neurons. 1, 2, 3, 4 up to 8 neurons I am taking. Then at the output, we are going to have 1. Then at the dense layer 16, that is from input to hidden, I am using the activation function called ReLU. And then H1 to H2 also, we are using one activation function called ReLU. Then dense to output layer, I am using the activation function called sigmoid. That means what? Every layer we need to apply any one of the activation function to convert nonlinear data into linear format. That's why from input to hidden layer, I am using one activation function called ReLU. From H1 to H2 also, we are using one function called ReLU. Then from H2 to output layer, I am using the sigmoid function activation function. So these activation function, for example, in the case of ReLU activation function, I am writing. So the mathematical representation of ReLU activation function is max of two values, whatever the values we have here. So if we have 1 and 2, we are going to get the 2. That is maximum of value we are going to produce with the help of ReLU activation function. In the case of sigmoid activation function, 1 plus e power minus x. This is the mathematical representation of sigmoid activation function. So whatever the weights from input to hidden layer, we have multiple weights are there. Hidden layer 1 to hidden layer 2 also we are going to have multiple weights are there. Hidden layer 2 output also we are going to have multiple weights are there. Based on the weights as well as inputs, either we are going to apply ReLU at the hidden layer and sigmoid at the output layer we are going to apply. So this is the basic structure. Input layer we have. At the hidden layer, 16 neurons I am taking. Then dense layer, 8 neurons I am taking. At the output layer, we are going to have 1 neuron. Then here you can see a input shape equal to 10 comma. That means what? At the input layer, I am taking 10 parallel inputs. 1, 2, 3, 4, 5, 6, 7, up to 10. One is connected with all these 16 neurons because we are using dense here. 2 is connected with all 16 neurons. 3 is also connected with all 16 neurons. Like this, the complicated structure we are going to have in the case of this particular artificial neural network structure. To solve this problem, we need to have multi-layer perceptron because single layer perceptron will not handle this nonlinear data. Now, to overcome that particular problem, we need to use multi-layer perceptron. So like this, how many neurons we are going to have at the input layer, how many neurons we are going to have at the hidden layer 1, number of neurons at hidden layer 2, then number of neurons at the output layer, how many outputs it is going to produce. Based on this, we can modify these particular values, we can modify these activation functions, and then number of neurons also we can change based on the requirement. That means what? If input shape equal to 10 input features it is going to accept per cycle. When it is processed, it is taking 10 input features from the real world. That means what? 10 inputs we are giving. From these 10 inputs, it is going to process 16 features at the first hidden layer, 8 features at the second hidden layer. By this, after processing this, it is going to produce 1 output. So like this, based on the requirement, based on number of features we are going to extract from the input data, we need to define the model, and then after defining the model, this particular, based on these input values, the Python will help us to compile the model. Here, when we are compiling the model, I am using Adam optimizer. Then loss, I am using binary cross entropy. That means to minimize the loss from when you are transforming the data from one layer to another layer. Matrix accuracy. So likewise, how many matrices you want to evaluate for that particular model, all these matrices I am writing like this. That may be accuracy, F1 square, loss, precision, recall, like this. Various matrices are there. How many matrices you want to calculate? All these matrices we need to measure here. Matrix equal to accuracy, comma, precision, comma, recall, comma, F1, like this. We need to close this brace so that all these matrices will be evaluated by the Python code. So the outputs are produced by this Python based on the type of matrices and number of matrices we used in that particular code. That's all. Thank you.